for the calculator section, you should be able to solve a problem that looks like this. Solve 3 to the 2x minus 4 power is equal to 120.31. And I'd like you to round your answer to the 10,000th. So what that means is just like any other time that we do logs, we're rounding our answer 4 decimal places. So if you'd like, you can go ahead and do these and just kind of double check with me up on the board, make sure we're doing the same thing. But the way that we solve logarithmic equations is or the way we solve exponential equations is we use logs. The way we solve log equations is we switch to exponentials. So for a problem like this, what I'm going to do is take the log of both sides. And what that enables us to do is bring the power down. So now we don't have any more exponential functions or anything in the exponential position. So what we could do is divide both sides by the log of 3. And we get 2x minus 4 is equal to log of 120.31 divided by the log of 3. And you guys should be typing this into your calculator too. Common mistake I see with this is that people type them in wrong. So let's just double check. I'm getting 4.3601. And then to finish, if we add 4 and then divide by 2, I'm getting x is equal to 4.1801. And that would be the answer here. Second problem is similar to what we saw earlier with log equations. So let's say we have a model. So the exponential model of b of t is equal to 175 e to the 0.07 t power describes the number of bacteria where t is in hours. And this is going to be a two-part problem. First part's going to ask you how many bacteria were present in the beginning. So in the beginning, does anyone know what time would equal? 0, right? So what we're going to do for part A is just say, okay, in the beginning, time is 0. So all we have to do is plug in 0 to our equation. And anytime you have anything to the 0 power, it's just 1. So the answer for part A is just going to be 175. For part B, it says, when will the number of bacteria triple? Well, this builds off the last part. So if we're starting with 175 and we want to figure out how long until it triples, what we have to do is take 175 and multiply it by 3. And we're going to go ahead and solve the equation 175 e to the 0.07 t power. And when we go to solve this, t is going to tell us when will the bacteria be 3 times 175. That's how it all comes together. So 3 times 175 is 525. Remember, we're going to solve this using natural log because there's e here. But to get to the e, we have to divide both sides by 175. And then to get rid of the e, we take the natural log of both sides. And then to finish it, you could just divide by 0.07. And I'm getting t is 15.6945. So about 15.5 hours would be the answer for this. And that's the calculator section. So the calculator section are just those 2 problems. Next, we'll move on to the non-calculator section. First question here, it says to solve for x. And it's a rational inequality. So we saw something like this on your very first exam. Let's take a look at a problem that looks like this here. Let's do x plus 5 divided by 2x squared minus x minus 3 is less than or equal to 0. We said for a problem like this, there's 4 steps. Step number 1 is we solve it like an equation. So we're going to do x plus 5 over 2x squared minus x minus 3 is equal to 0 over 1. and then you cross multiply. So 0 times 2x squared minus x minus 3 is equal to 1 times x plus 5. Or x plus 5 is 0, so x is negative 5. That's only the first part where we solve it like an equation. The second part is we figure out when is the denominator equal to 0. Well, that means we have to factor. So we're going to take 2x squared minus x minus 3 and factor it to figure out when that's going to equal 0. We spent a lot of time on factoring, so the way we do factoring is we make an x like this. We do 2 times negative 3. And we need numbers that multiply to be negative 6 and add up to be negative 1. So we could use negative 3 and positive 2. So we'll just write 2x squared minus 3x plus 2x minus 3. And just factor like we usually do. I'm getting x is 3 halves and x is negative 1. So first step is we solve it like an equation by cross multiplying. Second step is we figure out when's the denominator going to be 0. Third step is we make our number line and test values. This is where I taught you how to store on your calculator. So if you want to practice doing that, you could take out your calculator. And it looks like we have 3 values we're going to use. We'll plug them in order. So negative 5, negative 1, and 3 halves. We're going to test values less than negative 5, between negative 5 and negative 1, between negative 1 and 3 halves, and then numbers bigger than 3 halves. So I could use like negative 6 for this region, negative 2, 0, and then 2. And I'm going to plug these numbers in over here. When you store numbers in your calculator, like if we use negative 6, we're just going to type negative 6, store for A, and hit enter. But then we have to type the equation using the A variable. So we're going to type in parentheses A plus 5 divided by parentheses 2A squared minus A minus 3, and see what values make that less than or equal to 0. Okay. So when you go to type this in, the whole top has to be in parentheses, and the whole denominator has to be in parentheses too. You could also just plug these in by hand, but using a calculator is a little faster. So I'm going to type in parentheses mem variable A plus 5 divided by parentheses 2 mem variable A squared minus mem variable A minus 3. And I'm getting negative 0.01 is less than 0, which is true. So I'm going to circle that region. If I store negative 2, I'm getting 0.4 is less than 0, which is not true. So I'm going to cross that out. If I store 0, I'm getting negative 1.6 repeating is less than 0, which is true. And then if you put 2 in, I'm getting 2.3 is less than or equal to 0, which is not true. So before we get to step 4, which is testing the boundaries, let's write down what we have so far. So any value less than -5 would be from -infinity to -5, and then between -1 and 3/2. We just want to test to see if the boundaries work. So could x be -5, -1, or 3/2? Well, if you were to plug in -5, remember that's what we got when we solved the equation. So you'd get 0 is less than or equal to 0, which is true. So what that means for us is we're just going to write -infinity to -5, but we're going to put that in brackets. All right, question? Yeah, so this would be the non-calculator section. So I guess you wouldn't be able to store these numbers, right? So you would just have to plug them in by hand. If you were to plug in -6, by hand, -6 plus 5 is -1, divided by -6 squared is 36, times 2 is 72. 72 minus -6 is 78, minus 3 is 75. So even without a calculator, -1 over 75, is that less than 0? Yeah, right? So we could still do it without a calculator. But that is a good point. This is the non-calculator section, so you wouldn't be able to store it. If we were to plug in -1, that would make the denominator 0, which you're not allowed to do. So -1 wouldn't work. So you can't include -1. And then if you plug in 3/2, that would also make the denominator 0, which isn't allowed. So the answer would be this. So that's a lot of work. Let's move on to the second problem. Second problem on the first exam, you did really well on. That was with a circle. So what I'll ask you to do is just find the center and radius. And let's say we had an equation where it's x squared plus y squared minus 2x plus 4y minus 44 is 0. The way we did a problem like this is we had to complete the square twice. So what we did is we grouped the x's together, x squared minus 2x. We grouped the y's together, so y squared plus 4y. We got the -44 out of the way. Factored out the leading coefficient. So in this case, the leading coefficient is just 1. And then we had to complete the square for our third step. So what that means is you take the middle number divided by 2, square it, and that goes right here. So -1 squared is +1. 4 divided by 2 is 2. 2 squared is 4. That's the third step. And then the fourth step is you can't just add numbers to an equation. We have to multiply by the front and then subtract them. So we're going to subtract 1 here. And then we're going to subtract 4. So this would be x minus 1 squared plus y plus 2 squared. And if you bring these numbers onto the other side, this would just be 49. Remember, to get the center, we take the opposite of what's inside the parentheses here. So the center would be 1 comma -2, and the radius would be the square root of 49 or 7 units. So that's that. Third problem is going to be just some log problems. So it'll ask you to evaluate. Let's say we had a problem where it's the log base 2 of 16, the log base 3 of the square root of 3, 4 times the natural log of e, and then the log of 1. So these problems you should be able to do without a calculator. The first problem, what we're going to do is we're going to use the inverse property. So 16, well, I know 2 squared is 4, 2 to the third is 8, 2 to the fourth is 16, so we're going to say log base 2 of 2 to the fourth, and according to the inverse property, we're just left with 4 here. For letter B, we talked about logs don't like radicals. They also don't like decimals. So the way that we're going to do a problem like this is with our property, where if you have a fractional power, we could easily convert that to a radical and vice versa. So this is really the second root of 3 to the first. So converting this to rational exponents, we get log base 3 of 3 to the 1/2 power, which using the inverse property would become 1/2. Anytime you see natural log and e next to each other, that's just an inverse property. So this is 4. And then we talked about in class, anytime you have the log of 1 or natural log of 1, does anyone remember what that is? So the graph of log looks like this. And at 1, when x is 1, y is 0. That's the graph of log, and that's the graph of natural log. Okay. So remember the graph of log kind of looks like a hockey stick like this. We have a vertical asymptote where x is 0, and we also have an x-intercept of 1. Okay. So that's why log of 1 and natural log of 1 are both 0. Okay, next problem, you're going to have a piecewise function. We talked about piecewise functions before. So let's just take some time and just draw this correctly. You can make a graph that goes 10 units in each direction. That'll give us plenty of space here. And then if you could just recreate the graph I'm going to put up here. Let's put a point at -6, -5. And I'm going to make that go up until negative 2, 2. I'm going to draw a flat line from negative 2 to 3. And then I'm going to draw a parabola at 3, negative 6. To right here, which is 1, 2, 3, 4, 5, 6, negative 2. And then I'm going to have it go down from there. And I'm going to ask you to list or find a few different things here. Okay. So just take a minute, make sure you draw that accurately in your notes. I'm going to ask you to evaluate f of negative 2. Tell me what the domain is, the range, where are the intervals where it's increasing, decreasing, constant. And then the last question I'm going to ask you is to figure out what f of 3 is. Okay, so take a couple minutes, just make sure you have all that down accurately, and then we'll go through this. All right, so first problem says, what's f of negative 2? What that means is, what's the y value when x is negative 2? Negative 2 is right here. And it looks like we have 2 points. We have an open circle and a closed circle. If we want to know what the actual value is, we have to go to the closed circle. So it looks like that answer is going to be negative 2, 2. So the answer is, what's the y value when x is negative 2? The y value would be positive 2. Domain means what are the possible x values? X values obviously go left to right. So if you look at it, it looks like the graph starts right here at negative 6. But there's an open circle there. So we're going to put parentheses around negative 6. And it looks like there's values up until forever, because that line means it keeps going. So we're going to say the domain would be from negative 6 to infinity. Even though there's some discontinuities there, meaning that there's like jumps and open circles, there are still x values for every there are still y values for every x value from negative 6 to infinity. The next thing is the range. Range are the y values. If you look on the right of the graph, that arrow is pointing down, so it looks like it goes down forever. So the range would be from negative infinity. And the highest the graph goes is when y is 2, including 2. So we're going to put the 2 in brackets. When is the graph increasing? Well, that means going up from left to right. So it looks like from here to here, the graph's going up, and from here to here, the graph's going up. So those are just domain values. So we're just going to write, and they're always in parentheses too. So we're going to put from -6 to -2, and then from 3 to 6. Where is the graph decreasing? Well, that means going down from left to right. It looks like that happens right here. So that's after when x is 6. Constant means the graph is level from left to right. So it looks like it's from -2 to 3. And then the last question is asking us to do like a double decker. It's asking us to figure out f of 3. So first thing let's do is let's figure out what the y value is when x is 3. So 3 is right here. It looks like we have an open and a closed circle. So let's go with the closed circle. When x is 3, the y value is -1, 2, 3, 4. This point right here is 3, -4. Just as a friendly reminder, you should be circling your answers so I know exactly what you're telling me to look at. And then the last part is, what is f of -4? Means what's the y value when x is -4? So -4 is over here. If you look at the graph, it looks like that point right there. So when x is -4, the y value looks like it's -2. Okay. So there's a couple different parts to that problem. I'll give you a second to make sure everything's okay. We'll move on to the next part. Problem number 5, it gives us an equation y is equal to the log base 2 of x minus 2 plus 4. And it's going to ask us to do a few things. It'll ask us to graph it. And it'll ask us to find the domain, the range, the asymptote, the y-intercept, and then we're just going to graph it. Well, when we're talking about logs, we said you can't take the log of anything less than or equal to 0. So whatever's inside this argument here has to be greater than 0. So in order to figure out the domain, we're going to go ahead and solve when x minus 2 is greater than 0, and we get x is greater than 2. The way we write that in interval notation is we say from 2 to infinity. We usually get the range by looking at the graph. So we know that the log graph usually looks like this. If you put -2 on the inside of the graph, what does that do to the graph? It goes to the right. We're going right 2, and then we're going up 4. So we're going to move this graph to the right 2, and then lift it up 4. It's going to look something like this. Usually the asymptote is at 0, but if you move the whole graph to the right 2, now the asymptote's going to be at 2. So we're going to say the asymptote is when x is equal to 2. We know that the range of log graphs goes from -infinity to infinity. And then the last part is we have to figure out the y-intercept. It doesn't look like this graph has a y-intercept. The way you would usually get the y-intercept is you plug in 0 for x. So for this graph, it doesn't cross the y-axis at all, so this isn't going to have a y-intercept. If you try to do it, you get log base 2 of -2. And you know that there's no solution for this. So there's no y-intercept. And obviously that's because this graph went to the right. If instead the graph went to the left, so let's just say we had another problem, and let's say the graph was y is equal to the log base 2 of x plus 4 plus 1, and we're trying to get the y-intercept of this. Obviously, this graph goes to the left 4, so to get the y-intercept, you'd plug in 0 for x. You just get log base 2 of 4. We know that 4 is really just 2 to the second power. So the y-intercept for this graph would just be 2 plus 1 is 3. Okay, obviously that's a totally different problem. I just want to make sure that you know how to handle those. So that's graphing log equations. The next one is a difference quotient problem. Okay, so problem number 6. It asks us to find the difference quotient and it'll tell you the difference quotient. It's f of x plus h minus f of x divided by h. And you should know how to do this for a rational equation. So it's a little bit different than some of the other examples we saw. So let's say if the problem was f of x is equal to 1 over x minus 2. Okay. So we're still going to do the difference quotient. And remember, the difference quotient came in 3 different parts. First thing we're going to do is we're going to plug in x plus h for all the x's. So I'm going to do 1 over x plus h minus 2, and then subtract f of x. So we're going to subtract 1 over x minus 2. and then divide the whole thing by h. So the way we have to do this is we have to combine the top by getting a common denominator, and then we'll take care of that h on the bottom. So the way we're going to do that on top is we just have to get a common denominator. It looks like the least common denominator is going to be the x minus 2, and we're also going to need an x plus h minus 2. So what we're going to do is we're going to get that denominator under each fraction in order to combine them. So for the first fraction, we're going to have to multiply by x minus 2 over itself. And then for that second fraction, we're going to have to multiply by x plus h minus 2 over x plus h minus 2. So we're just trying to combine fractions here. What this turns into is x minus 2 over x minus 2 times x plus h minus 2 minus x plus h minus 2 over x minus 2 times x plus h minus 2. We're still dividing the whole thing by h. Now that we got a common denominator, we can go ahead and combine the top two fractions. Remember to distribute this negative, and we get x minus 2 minus x minus h plus 2 over the denominator. We'll just go ahead and multiply this out. X squared plus xh minus 2x minus 2x minus 2h plus 4. And we're dividing that whole thing by h. Usually whenever we do these kind of problems, we get a lot of terms that cancel. So in the numerator, the x's cancel, the 2's cancel. We get negative h on top. In the denominator, we get just x squared plus xh minus 4x minus 2h plus 4. And when you divide by anything in math, it's the same thing as multiplying by the reciprocal. So just to finish it, if you're dividing by h and multiplying by h, your final answer is just going to be negative 1 over x squared plus xh minus 4x minus 2h plus 4. All right, I'll give you a second to make sure you have all that down. All right. Move on to the next one. Next one is rational root problem. So this is problem number 7. It says find the zeros and let's do something like this. X to the third minus 4x squared plus 6x minus 4. So even though that's what the problem's going to say, I would still like you to do the 4 steps that we talked about in class. First step for these is we figure out the number of positive roots. Next, we figure out the number of negative roots. We list the P over Q values, and then we find the roots. So you should be able to do this on your own, and then we could always just check with each other. For the number of positive roots, we're looking to see when do the X values change sign. So we have a positive, negative, positive, negative. Looks like there's 1, 2, 3 changes. So we say 3 or 1. From positive to negative's a change, negative to positive's a change, positive to negative's another change. So there's 3 changes, yeah.
Can you tell if it's 3 or 1?
So you always subtract 2. The question is, how do you know if it's 3 or 1 or 3 or 0? It wouldn't be 3 or 0 because that's subtracting 3, right? We always want to subtract 2 from the number. So it's 2 or 0, 3 or 1. For the number of negative roots, we change the signs of the odd powers of x. So it's going to become negative, 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 negative. It doesn't look like there are any negative roots. So when it comes time to testing which ones work, why would you test anything that's negative? You know that there's not supposed to be any negative roots. The P over Q values, remember P represents factors of 4, bless you. Q represents factors of 1. So factors of 4 would be plus or minus 1, 2, and 4. Q represents factors of 1. But remember, if there's no negative roots, it doesn't make sense to say that negative 2 would be a root because you know that that's not true. So you're just going to tell me 1, 2, or 4. And also make sure that you're circling your answers as you go through this, so I know what you want me to grade. Yeah. So the question is, how do you find P and Q? P represents factors of the last number. So the last number here is 4. What are numbers that evenly go into 4? 1, 2, and 4. Q represents factors of the first number, which is 1. Factors of 1 would just be 1. So then you just write 1 over 1, 2 over 1, 4 over 1. When we go to find the roots, we're looking, where does the remainder equal 0? So if you guys would like, why don't you do this? I'm going to do it too. And if you find something that works, just let me know for the benefit of the class. So I'm going to do synthetic division with 1 first. Remember, anytime we do division, if we're missing a term, we have to plug in 0 as a placeholder. So for this problem, I'm going to do synthetic division. Remember, we add going up and down, and we multiply on the diagonal. 1 times 1 is 1, so this would be negative 5. Negative 5 and 6 is 1. So it looks like we get a remainder of negative 3, which means 1 is definitely not a root. All right, well, maybe it's 2. If 2 doesn't work, maybe it's 4. So let's try 2 now. 1, -4, 6, and -4. 2 times 1 is 2. This would be -2 and -4. This would be 2 times 2 is 4. And we get a remainder of 0. So we know that one of the roots is definitely 2. We get the depressed polynomial. And from here, we want to figure out what the other 2 missing roots are. Now, if you try to factor this, you're going to get stuck, because nothing multiplies to be 2 and adds up to -2. So it looks like for this, you could either complete the square if you want, or you could use quadratic formula. Using quadratic formula, we're taking the opposite of -2, plus or minus the square root of b squared minus 4ac, all divided by 2a. 4 minus 8 is -4. And then you want to make sure that you always simplify when you're telling me the answer. So when we have to do the square root of -4, remember that's really the square root of 4 times the square root of -1, or 2i. And if we're dividing by 2, we saw this on the first exam, just make sure you're doing 2 divided by 2 and 2i divided by 2. So the answer would be the roots are 2 and then 1 plus or minus I. So it looks like we got 1 positive root. There are no negative, and the other 2 roots are imaginary. So we still have 3 total. 1's positive and 2 are imaginary. All right. Moving on. Problem number 8, it says we have the function f of x is equal to 2x plus 1 over x squared minus 16. And what we have to do is we have to graph this and then find some different components of it. So the question is going to be, what's the domain? What are the asymptotes? So the equations of the asymptotes. Remember, we have horizontal and vertical asymptotes, so we're going to have to find both of those. Next question is we're going to have, just going to write horizontal asymptote and vertical asymptote so we don't forget. Next one is we have the intercepts. When we're listing the intercepts, we have the x-intercept and the y-intercept. So we'll figure out those. And then the last thing the problem asks you to do is to sketch the graph. So in your notes, why don't you go 8 units in each direction? That should give us plenty of space, and then we'll go ahead and answer these. So when we talked about graphing rational functions, remember we said first step is we want to see if it factors. Looks like the bottom factors, but nothing's going to cancel out with the numerator. So the next step is we find the vertical asymptotes. The way you get the vertical asymptotes is you set the denominator equal to 0. So the way we get the vertical asymptote is we say x squared minus 16 is 0. So x would be positive and negative 4. You can go ahead and write that for our answer, positive and negative 4. And then we'll put that on the graph. And just go ahead and label it. That affects our domain because remember, your denominator can't be 0. Your denominator is going to be 0 at 4 and negative 4. So the way you would list the domain is you would say from negative infinity to negative 4. That covers this piece. From negative 4 to 4, that covers the middle piece. And then after 4, you would write 4 to infinity. So that's how we would write the domain. Next thing we're looking for is the equation of the horizontal asymptote. Well, when we talked about finding the horizontal asymptote, we said we have to look at the degree of the numerator and the degree of the denominator. And the degree on top is smaller than the degree on the bottom, which means we have a horizontal asymptote when y is 0. We'll go ahead and draw a horizontal asymptote like that. The way we get the intercepts, just like for any other graph, we get the y-intercept by putting 0 in for x. So we just get y is equal to negative 1 over 16, which we know is just below the the x-axis. To get the x-intercept, you have to make y equal to 0. So if we do 2x plus 1 over x squared minus 16 is 0, cross multiply, you just get 2x plus 1 is 0, so x is negative 1/2. And then the last part is we just have to draw the branches. So in order to do the branches, we have to test values. So just make sure you're careful when you're doing these in your head. I'm going to test values to the left of negative 4, like negative 5, and I'm going to test values to the right of negative 4. So I'm just going to add 1 and subtract 1 to all the vertical asymptotes. Same thing with the positive 4, I'll subtract 1 and then I'll add 1. And we're plugging those into our original to see where the branches are going to lie. Now, when you're doing this yourself, just be careful plugging them in. If you plug in negative 5, on top you were to get negative 10 plus 1 is negative 9. And on the bottom, 25 minus 16 is positive 9. So what this means is when x is negative 5, y is negative 1. So I'm just going to put a point below, and my branch is going to be below. If you plug in -3, you get on top -6 plus 1 is -5. In the denominator, 9 minus 16 is -7. So that means the point -3, 5/7 is on the graph. If you plug in 3, 6 plus 1 is 7. 3 squared is 9 minus 16 is -7. So the point 3, -1 is on the graph. So it looks like the middle, you have a point above and a point below. We said the way that we graph that is by drawing a cubic function. And then for the last branch, if you were to plug in 5, 10 plus 1 is 11. 25 minus 16 is 9. So you get the point 5, 11 ninths. Obviously, that's a positive number. So you put a point at 5 in the positive region and then just connect your dots to get the branch. All right, let's move on to some other problems with logs. Problem number 9 just says expand fully. And let's say we had the log base 3 of the cubed root of 7x to the 4th divided by y to the 9th. Obviously, we're looking to use the power property, quotient, product. First thing I would do is I would get rid of that radical by making it to the 1/3 power. The more properties you use, the more points I can give you. So I'm going to make this to the 1/3 power and then bring that in front. So that's the power property. And remember, right here was the property where a fractional power means the nth root of x to the m power. So step by step, that's what we're doing here. Next, it looks like we have a quotient. So the way we handled the quotient was by subtracting. So what we're going to do with this is remember to keep the parentheses because it's 1/3 times the whole thing, but it's going to be the log base 3 of 7x to the 4th minus the log base 3 of y to the 9th. Then it looks like we have a couple more power properties and a product. So right here, I could use another product property. And right here, I could use a power property. So I'm going to write this 1/3 times the log base 3 of 7 plus the log base 3 of x to the 4th minus 9 times the log base 3 of y. And then we have one more power property. So the final answer would be 1/3 times the log base 3 of 7 plus 4 times the log base 3 of x minus 9 times the log base 3 of y. Problem number 10, we're going to solve for x. And the problem says log base 3 of x plus 1 plus the log base 3 of x plus 3 is equal to 1. So looking at this problem, we have a plus sign. If there was a minus sign, obviously you would divide the arguments, but because this is plus, that means the product property. So we're going to do the log base 3 of x plus 1 times x plus 3 is equal to 1. We talked about earlier, the way we get rid of log is by writing in an exponential form. So this will be 3 to the first power equals this. And then it looks like we just have to distribute, make it equal to 0, factor, and solve. Just remember that you can't take the log of a negative either, so we just have to check for extraneous solutions. This would be 3 is equal to x squared plus 4x plus 3. Bringing the 3 on the other side, we just get x squared plus 4x you could factor out an x from here and then set each factor equal to 0. So we get x is 0 and x would be -4. Maybe. We just have to check to make sure that that doesn't make the argument of any of the logs negative. If you were to plug in 0, it looks like that works. You wouldn't be taking the log of a negative, so that's all good. If you were to plug in -4, you'd have to take the log of a negative, and that's not allowed. So the only answer for this would be x is equal to 0. And then the last problem is dealing with inverses. It's problem number 11. Problem number 11, it says we have the function f of x is equal to x to the third minus 4. We want to find the inverse. All right, so let's do that first. Part A is we're going to find the inverse. And remember, we said that that was a 4-step process. First step is you write y instead of f of x. Next step was you switch x and y. The third step is we have to solve for y now. So I'm going to add 4 on both sides. And then go ahead and take the cubed root and we just get y is equal to the cubed root of x plus 4, which would be the inverse. Part B is we want to confirm that f of x and f negative 1 of x, the inverse, are in fact inverses. So the way that we talked about doing this in class is we said we're going to do f of the inverse, and that should equal x. So let's go ahead and do this here. It looks like the inverse was the cubed root of x plus 4. And we're going to go ahead and plug that in for the f in f of x. So we're going to cube that. And then we just get x plus 4 minus 4, which gives us x. Okay. That's what you have to show. So they would be inverses if the composition of the two just gives you x. And that's exactly what we showed here. And then the last part is we want to graph both on the same graph. So we're going to graph f of x and the inverse. Now the original function was x to the third minus 4. And the inverse was the cubed root of x plus 4. So this is using our understanding of graphing transformations and parent graphs. Remember, x to the third looked like a cubic function like that. It goes up from left to right. So it goes down to up. And then the cubed root looked kind of like this. It almost points left to right. This graph is going to go right 4. This graph is going to go, this goes down 4. It would go right 4 if it was inside of the cube. And the inverse is going to go left 4. So if you could sketch a graph, let's go 6 units in each direction. And then we'll go ahead and graph each. The original function I'll graph in red. So this graph is going to go down 4 units and look like a cubic. So it'll look something like this. And let's go ahead and just label this f of x. And then the inverse is going to go left 4. and take on this shape. Remember we said when we're graphing inverses, one easy way to check is that the graphs look like they're reflected over the line y equals x. So if you just switch the x and y values, like this point right here is -4, 0. If you were to switch the x and y values, it becomes 0, -4. This point right here looks like it's 4, 0, 4. And if you switch them, it looks like this point right here, which would be 4, 0. So we know that we got this correct because all of the points look like they're reflections over the line y equals x.